Okay, well, here we are, back at it, Math 150, beginning algebra, and we're going to take a look at the next section, which, bringing this up on my document camera, you're going to see that it's on negative exponents and scientific notation. Negative exponents, scientific notation. So those of you that are taking this class and have the packet / my instructional manual, you're going to see this funny little thing in here that I'm asking you to sign a document. Basically, it's getting your attention because we're dealing with negative exponents, and at the end, when you're all finished, you don't want negative exponents left in your answers. Your answers can't have negative exponents. So the question is, how do you deal with them? And that's what I'm going to show you. So you could put your name in here. You can actually do it, or just remember that you're just not going to have any negative exponents, positives only. The only exception that you could have is something called scientific notation, which we're going to take a look at today as well. And then you're also going to agree that if you've got something, what this means, if you got, say, 3 to the second, you don't leave it as 3 to the second, you're going to give me 9. Versus if you have 12 to the second, you could leave it as 12 to the second, or you can make it 144. Anything that's 100 or less, I have to have 9 in this case. Otherwise, I have a choice. So you sign your name and start trying to do the problems. Now, these rules right here are basically saying that if you've got a negative power, you can move the base and the power across the division line. And what'll happen is you're going to change the sign of the power only, So like, for instance, notice this one. If I saw a to the negative something, I can bring it down as a to the positive something. So I'm just moving it across the division line and changing the sign of the exponent. Or some people think about subtracting powers. See, so I can move this up. So if I move it up, of course, it's negative n. So top minus bottom as an example. Negative exponents are really fractions. That's true. Negative exponents fractions. So I have to have 2 to the negative 1. This is a fraction. It doesn't look like it, but it's the same as 1 over 2 to the positive 1. That's what this is saying. 2 to the negative 1 is the same as 1 over 2 to the positive 1. That's all I'm doing right here, or half. Make sure everything's a quotient, and then you can either cross the division line and change the sign of the exponent, or you could subtract the smallest number from the largest number, exponent-wise. So let's take a look at some examples and show you how it works. All right, so first one, this is a fraction. No, it's not yet, but it will be. This is a fraction. Negative exponents or powers are fractions. The whole thing is fractions. So you're going to go and bring the 4 down. Don't change the sign to the 4. Change the sign to the exponent to a positive 2 from a negative 2. And you got to leave something in its place, so it's 1 over 4 squared, which is 1 over 16. Remember, it's not 4 times 2, it's 4 times 4. Problem looks like this. You're going to go 1 over 6 plus 1 over 3 squared. Then you got to deal with the fractions. So 1 over 6 plus 1 over 9. LCD, you got LCD, you have, let's say 18. So then what you're going to do is make all the denominators 18. That means multiply by 2 there, and 2 there, 3, and 3. So then you simplify, you go 3 over 18 plus 2 over 18, better known as 5 over 18, and that itself can't be reduced. Next problem, put a 1 like this. It feels like this one, so it'll be 1 over something. Feels like the same thing, so it's 1 over. Now, you're not going to switch the direction, excuse me, you're not going to switch the sign of the base. That stays the same. You're going to switch the sign of the power and make that a positive 4, and then finish up the problem, meaning -2 4 times, -2 times -2 times -2 times -2. That's 16, 1 over 16. Positive, because 4 negatives are a positive. Now this one's interesting. I could go ahead and multiply the exponents right here, use rules for exponents. So the 1 times -2 and the 1 times -2. I could rewrite this as 1 to the -2 power over 2 to the -2 power. And then following the, I think it's the last rule over here, following the last rule. No, the middle rule right here. All I have to do is just move everything across the division sign and then change the sign of the exponent. So when I do that, I'm going to take the 1 and change the power from -2 to +2. Take the base 2 and change that to a +2, and then finish up the problem, which is end up being 4 over 1, which is just 4. I mean, 4. 4 is the best answer. You know that. Okay, here, a couple ideas. You could simply say there's 3 9s and 5 9s. You could do this. 2, 3, 4, 5. You could do this and just say 1 for 1. That'll work. And then you say, well, what's left over? Got to be a 1 up in the top. 9 times 9 is 81. You could do that. You could also subtract the powers. And what you do is you subtract the smallest from the biggest, meaning bring the 3 down there. The smallest is 3, so 5 minus 3 down below would be, well, like that, would be 9 squared. So it's down below. You got to bring this down below because that's small. Bring it with the bigger one. So the 3 is going to change to a -3 if you do it that way. Jeff, what do you mean? Okay, so this would be 9 to the 5 minus 3 is 9 squared, which would be 1 over 81. Okay, this one here, I'd probably move all the powers that are negative across the division line. I'll keep that one where it is. So this one here goes downstairs as x squared. This one here goes downstairs, and that's y to the 5th. This one here goes upstairs, and that's x to the 1st up above. Leave that where it is because we're happy with a positive power. And then this one here is going to go up above the z. Okay, simplify. Let's see, I got x z cubed over x squared. Add exponents. Base is the same, add exponents. And then this can be reduced here. So you have an x left over down below the first, which I don't need to write the first power. And z to the 3rd. So if I haven't made a careless mistake, that should be the final looking answer. This one here, you could use rules for exponents. It says base is the same, you add exponents. So it's y to the -3, add exponents, plus 4. Hey, y to the 1, or plain old y. Okay, gosh, a couple things going on. I don't like negative exponents. I don't like this, but I could use the rule that says I multiply exponents first and see what happens. I think I'll do that. So I'm multiplying these 2 exponents, also here and there. So that's, what is that? X to the -1 times -2. Multiplying exponents. Z to the 3rd times -2. Multiply exponents. Here we're going to end up with x squared. That's a good thing. +2 is good. Y to the -2. I'm going to have to move that one. and then z to the -6. I'll have to move that one as well. So these two right here get moved. That and that's going to have to move across the division line. X squared stays in the numerator. So y squared down below, z up above, change the sign of the exponent. Finally, on this one, the bases are the same, so same idea. I could add exponents, so that would be 3y. 8 subtract 7 is 1, so in this case, 3y. Okay. So now, scientific notation. What the heck's that about? Scientific notation is used in areas where if the numbers are super big or super small, then it's a nice compact way, like right here. That is a nice compact way of saying, like this one here. That's the same as 30 right there. 3.0 times 10, or 3 times 10 is 30. That's not a very big number, but this is a huge number. If you took 3.145 times 10 to the 8th, you're going to get a big number. I'll even show you right here. If you take 3.145, and then you multiply that by 10 raised to the 8th power, you get a pretty good sized number. This is called decimal form or standard form. This is called scientific notation. And there's two things, or two instances, or two conditions that it has to be in scientific notation. The decimal placement. The decimal placement's always to the right of the first non-zero digit. 3's not 0, so 3 point. You're going to put the decimal to the right of the first number. So you would put the decimal right there. And then to get the 8, you're just going to count from way at the beginning where the decimal is. And you don't see the decimal, it's right here at the beginning. And count to the left. So it'll be 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 gaps. That's why it's 8. And the reason why it's a positive 8, now this is the way I do it. Whether it's positive, or you can see some of these might be negative, like that's a negative. The way I remember is you count, and I did say left, so be careful. Left might indicate that it's -8, but it's not. This is a big number. Big number, positive powers. Big number, positive powers. Small number, negative powers. That's a negative power, so it's going to be a small number. This right here, if I were to rewrite this in standard form, I need to move the decimal 3 places, but I have to decide which way to move it to make it a small number. I got to move it this way. So 1, 2, 3. And you insert zeros in its place. So this number right here is the same as that decimal. I'll show you. 4.1 times 10 raised to the -3. I believe that was what it was. And yeah, 0.0041 right there, 0.0041. So all of these are in scientific notation because you've got a 10 raised to a power, and integers are positive or negative counting numbers. No fractions. So, okay, these all have base 10s, but the reason why these guys are not scientific notation, well, this one's not a base 10. I mean, it's a base 10, but this one's not a whole number or a integer. The decimal is not placed correctly here. That's why this is not scientific notation. The decimal is over here, not right after the 3. And in like manner, the decimal needs to be where the 4 is, and it's not. So this is not scientific notation. So if I were to write this in scientific notation, there's the decimal. I just count in between the numbers. There's 1, 2, 3, 4, 5, 6. So it's 4 point, because that's where I want the decimal. 3, 0, 8, 0, 8, 8. times 10, and I counted 6 places, so that number times 10 to the 6th. Over here, well, I'll do these later. These are a little different. This is scientific notation, all of these guys, and then what you want to do is turn it into standard form. So let me finish these up and do these in scientific notation. The decimal has to be right there, 4.5, and then count the gaps. 1, 2, 3, 4, 5. Okay, so there's 5, but because that's small, this is a small number. Small number means negative. Big number means positive. Small number means negative. So, oops, it's got to go times 10 raised to the negative 5, times 10 raised to the negative 5. Now these two, you know, it's that one there and then that one. These two are not in scientific notation. I want to write them in scientific notation. So what I want to do is I want to put the decimal right there for 0.932 times 10. So this is a big number. So I want to add another movement over to the 1. I want to add another power to this one. So this would be 10 to the positive 6. This is the same as that. You can put those in your calculator and make sure that the decimal answers are exactly the same. They will be. This one here, same idea. You're going to go 1, 2. So 3.4 times 10. Okay, there's already a negative 5. And since this is a small number, small, it's a negative 2. So 3.4 times 10 to the negative 7 times 10 to the negative 7. Now these guys go backwards. So that means move the decimal so that they're in standard form, no powers. So this means big. Big. Positive power means big. This is small. Small. Big. So if I'm going to take, let's see, 3, 1, 4, 5. To make it big, I'm going to go this to the right here. So let's see, 1, 2, 3, and add a bunch of numbers, zeros. 4, 5, 6, 7, 8. If I took 3.145 times 10 to the 8th power, I should get that. Here, you can check it with your calculator if you wanted to. Take this, 3.145 raised to the, times 10 raised to the 8th power. And just count the zeros. 1, 2, 3, 5. Let's see. 1, 2, 3, 4, 5. Yep, that works. This one here, of course, you can use your calculator if you need to. Times 10 raised to the negative 3. 0.0041. Same thing here. That would be 5.1206 times 10 raised to the negative 2. Okay, point 0. Okay, 51206. That 0 is important. If you thought about moving the decimal 2 places right here, 1, 2, and you got to put a placeholder for 0. That's why the 0 is there. And this one here is 206, so move it 3 places. So 1, 2, 3, put another 0 there. Scientific notation, Okay, so I think we have finished up. Until next time, have a good day. That is section 5.5 in the textbook that we've been using, which is Martin Gay, 7th edition. Take care.